In this video, I'll show you how to build a new computer using the 8080A microprocessor. Why build a new computer with a 50-year-old CPU like the 8080A? Well, I suppose it's for nostalgia and a challenge. Back in the 1970s, home computers were invented, and training kits like the MMD1 became available. I remember training with that kit and then building a few microcomputers of my own. Let's build a new one. First, we have to decide what the computer will do. Those early computers had lots of switches and blinky lights and maybe a speaker for making music. I think that's boring. Instead, I want my computer to play text-based games like those in 101 Basic Computer Games, edited by David All and published in 1978. Let's begin by cracking open the Intel 8080 User's Manual printed in 1975. The heart of this microcomputer will be the 8080 Central Processing Unit, or CPU. I want this design to be simple so that anyone can build one just like mine. The 8080A system components will make designing this computer very easy. Here's a diagram showing my computer's architecture. The control unit is an 8080 CPU, which can address 64 kilobytes of memory, divided between program and data. One serial interface is needed for communication with the terminal, and another for flash drive mass storage. We will need these enhanced system components: the 8080A CPU, 8224 clock generator, 8228 system controller, and 8251 programmable communication interface. Our 8080 User's Manual shows the pinouts of each integrated circuit, but how these are wired together is best visualized with a schematic capture software, such as KiCad. This software is available for free, and I have used it to lay out the computer schematic. This schematic has four main sections: the 8080 system components, memory, input-output, or I/O, and power. I will discuss each one of these in more detail. The 8080A CPU is a 40-pin chip supported by the 8224 clock generator and an 8228 system controller. An 18 MHz crystal is connected to the 8224, which divides this frequency by 9 to generate the 2 MHz system clock. A reset circuit also connects to the 8224, which has a capacitor that slowly charges to provide a 200 millisecond delay after power on before the CPU starts running. The 8228 bidirectional bus driver decodes the memory and I/O read-write control signals and handles one interrupt. Program memory is provided by a single 82C256 EEPROM, or E²PROM, that's mapped to the lower 32K addresses. Data memory is a single CY7C199 SRAM, or static RAM, mapped to the upper 32K addresses. Decoding the addresses is done with a 74LS04 inverter. Serial input and output is done with two 8251 interfaces. One interface connects to a terminal through a MAX 232 level shifter and DB9 connector. The other interface connects to a flash drive through a USB controller daughter board. I purchased the daughter board from Hobbytronics. Both 8251 chips will operate at 9600 baud, and they need to be clocked at 16 times this speed, or 153.6 kilohertz. To generate this clock, I use a 1.8432 megahertz crystal oscillator followed by a divide by 12 circuit. Power to the computer will be provided by a 5-volt wall wart. One that is well regulated and has a 2 amp output will work. 2 other voltages are needed, minus 5 volts DC and plus 12 volts DC. These will be generated using DC to DC converters, followed by linear regulator ICs. An LED light indicates when power is on. Bypass capacitors are used near each IC to reduce switching noise. And that's all there is to it. After laying out the schematic, the printed circuit board design can be done in KiCad. The 2-layer printed circuit board is 127 millimeters by 170 millimeters, or about the size of a 5 by 7 inch photograph. The components are through-hole type. Here the front side traces are drawn in red, and the back side traces are blue. The PCB was ordered from JLC PCB, and the sockets, ICs, and other components were ordered from Jameco or Mauser, or if these two failed, eBay. Remember, some of these components are no longer manufactured and may be quite old. And here is the finished computer with everything soldered into place. Isn't it beautiful? The Intel 8080A CPU has a copyright 1986 mark on it. Now it's time to test our new computer. Because there's no operating system or other software installed, the next step is to write and run a simple test program. I start a text editor and then start typing the assembly language program. First, we need to initialize the 8251. We'll do that by sending a couple of zeros out and then 40 hex, which is reset. Next, we'll output the codes to set the 8251 mode and command. Next, we want to write the code to send a hello message to the terminal. We're going to pull the 8251, checking to see whether it's ready for the next byte to send to it for output. Each time the 8251 is ready, we send the next byte of our message. We'll do this in a loop until all the bytes are done. The hello message itself is, "Hello, Leonard." We'll save that file and then assemble it using the assembler that I've written. It assembles with no errors, so let's look at the output of the assembler. Now that it's assembled, our hello program can be loaded into the EEPROM using this programmer, a model TL866-2+. With the EEPROM reinstalled in the computer and the RS-232 cable attached to the terminal and power plugged in, we're ready to test the computer. First, start the terminal program Minicom. Next, plug in the power and we will see our hello message, or not. After debugging, I determined that the NEC 8224 chip was not working. I replaced it with an Intel version, plugged in the power, and hello, Leonard. Now that we have a working 8080-based computer, the nostalgia part of the project is complete. What remains is the challenging part, writing a floating point basic interpreter for this computer. You may be aware that complete basic interpreters are available for download. But what's the fun in that? I quickly realized that in addition to an assembler, I would need to write an 8080 emulator. That done, I dove into coding BASIC in assembly language. Some long time later, I finally have BASIC ready. Let the games begin. 8080 BASIC runs instantly from ROM. BASIC was originally created in 1964 to help students learn to program. Here's an example of a for loop. My version of BASIC does both integer and floating point math. Programs are saved and loaded from a flash drive. The classic book, Basic Computer Games, lists 101 games that can be played with my computer. One of my favorites is Super Star Trek, based on the original TV series from the late 1960s. Loading the program at 9,600 characters per second takes a little while. As captain of the starship Enterprise, your mission is to seek and destroy a fleet of Klingon warships, which are menacing the United Federation of Planets. These games are entirely text-based, without color graphics, yet they're surprisingly fun to play. Let's search for those pesky Klingon warships. Long-range sensors are detecting the enemy in quadrant Sirius 2. Red alert! Raise shields! Phasers! Fire!